few years ago, Joe, a student of mine called Ryan Hatton. It took me a whole year not to call him Ricky Hatton.
Yeah.
You know me and names. It's like every time I spoke to him, I said, don't say Ricky, don't say Ricky. He said to me, he's currently working on the jointing system.
Yep.
Okay, he was installing cables for new housing estates, and we come up with the PME, protective multiple earthing, when we're using a TNCS earthing arrangement.
And that's the system where you go along sticking earth rods in the ground and connecting it to your combined neutral and earth along its run.
Yeah, for the supply authorities meant to do that. And how many chambers do you see going up the road, Joe?
Well, do you know what's funny is when I was at college and I was taught this by my lecturer at the time, a chap called Clive, hope you're still around, Clive, lovely bloke. He pointed this out to us, he described this and then went, but I've never seen this done in the real world, they don't do it. And he was our science and principles teacher, not our installation teacher, and he kind of went, I don't know why. And that kind of always stuck with me, and today we're going to find out why.
Yeah, so the legacy system that we've got in place, probably they didn't multiply earth the neutral as it went through its run. So they didn't put the PME in place. I know in some cases what they used to do is on the old cables, they used to strip off the outer sheathing and just leave it a bit bare in the mud. Okay, but they certainly, and I haven't seen a chamber anywhere at my street, seen any earth rods being driven in. But he went away and he started panicking because he thinks I do joints every day and I don't put any earth rods in. And Gary's told me in lesson that I have to in order for it to be a TNCS earthing arrangement. So he went away, panicked everybody at work, and then sat in the back of his van, Joe, and put this together to prove himself right and me wrong.
Well, thank you very much, Ryan. We're always glad to be proved wrong. No problem with that.
So what we've got here is actually, and we're going to bring the camera in nice and close in a minute, what we've got here is a system that doesn't actually break the protective earth neutral.
Right, so what we're talking about is under the old system of splicing cables and putting new connections to new properties on, this cable would have been cut through, which obviously creates a weak point. It creates a joint that could fail. However, what we're looking at under this modern method is that as we bring the camera in and see closer, the conductors have not been broken, which therefore means that the chances of you losing this protective earth neutral connection is pretty much zero.
Yeah, it is. So he was putting in like 2,000 metre runs or 1,000 metre runs, etc., with absolutely no, every time he joins it, no earth rod going in the ground, therefore no staking of the combined neutral earth.
So a different method of proving, of making a pen system safe.
Yeah, so bring the camera in, we'll show you what's going on in there. Cool. So Ryan sat in the back of his van and put this joint together, something you did every day, okay? So we've got here, and it's difficult to see, so that's why I brought an older colour one out. So what we've got here is our concentric cable with our old-fashioned red. We've got brown here. It becomes difficult to see within actually in the joint. Just remind me what material the line conductor is made of, Joe?
Yeah, so inside there you can see that this is sort of a silvery colour, that's aluminium, and then the conductor's wrapped around the outside. People often mistake this for armoured, steel wire armoured cable, don't they? This is a copper conductor wrapped around the outside. And that is your line conductor coming into your single phase property, and this is your combined neutral and earth conductor. So it's this kind of cable that you'll find on a TNCS system where the neutral and the earth are combined up to the origin of the property and separated from there on.
And the big issue is if we lose this conductor, we don't just lose our neutral, we also lose the protective conductor with the installation. And then obviously there's other ways that neutral current can find its way home. It could find its way home maybe through the metallic water pipe or metallic gas pipe. And there's big issues there around broken pens. So of course we reiterate it over and over again in the classroom, and these are linked to a set of notes that me and Joe have put together. But let's look at what has happened inside the joint to solve the problem, which is what I really like. Now, my three-phase conductors, so we've got brown, black and grey. Okay, brown, black and grey conductors. What have they not done to those conductors that would have done in an historic one?
Yeah, so you can see that this hasn't been cut through at all. All that's happened here is that they've separated the conductors out slightly. They've very carefully removed the insulation and then peeled back the copper armouring around the big cable so as to expose the aluminium conductors here that are insulated, and then they've just cut away a tiny little bit of insulation here. It's a really neat job actually, and it's a beautiful job he's done.
It was a good
and you can see there that then there is a clamp onto that aluminium cable. So these conductors haven't been cut. Even the one that we're connecting onto and taking a supply off has not been cut through. Therefore, the line conductors have actually maintained their integrity throughout.
So by not breaking the line conductor, we obviously probably won't lose that line conductor. Yep. We've clamped onto it, but what sort of material have we clamped onto our aluminium conductor with here?
You can see that that's aluminium throughout. So you've got aluminium conductor, you've got an aluminium clamp, and you've got an aluminium conductor going out to the new property.
And why is it so important to keep the metals the same, Joe?
It's important because you get an effect called galvanic corrosion, which happens if you've got certain metals that you connect together. If they occupy vastly different spaces on what's called the galvanic scale, the metals will start to damage each other and could deteriorate to the point where actually they break down completely, and actually this could snap off. We'll have a little chat about another example of that in here in a minute.
So we didn't break the line conductor and we connected to the line conductor going into the property. They also didn't break this outside protective earth neutral. So if we look on this cable here, just for a little bit of a design, we can see it's convention with the way we have a steel wire armoured. It's actually been done by design. So when it's opened out, Joe, you can actually pull it off the cable itself.
So it doesn't spiral so much as wave along there.
Absolutely. So this here, made of copper, is our neutral and protective conductor. So it's our combined conductor.
And that's actually probably even more important than not breaking the line conductors, isn't it? The fact that this solid copper conductor passing through here, which is our combined neutral and earth, has not been broken. That's probably more important that that's remained a solid connection throughout than the line conductors.
So by not breaking into my protective earth neutral, I can't lose it.
Yes, you've not created a weak point.
You haven't created a weak point. Now people go, well, we have, because obviously we've got to connect our cable onto it. But that's always been the case. The cable that goes, in this case, this concentric cable that goes up to the installation and into the bottom of our cutout, has never been staked at all. No. It's just one conductor from the joint. It was always historically the joints that fail, and when the joints were failing, it was potentially the neutral and earth that we were losing, Joe. No stakes, so obviously it caused us a massive issue. What I also like about this is the way that they've actually connected their neutral earth. So it comes off here. I know it's difficult to see. So it comes off here and it goes under this clamp. Joe will talk about that in a minute. It comes all the way around here and is actually connected onto both sides and clamped again.
Talk about belts and braces. So you've got two connections, and you'll notice that these haven't got a head on them. So these are cranked up to a particular setting, and when you reach a specific tightness, the head just shears off. Absolutely. So you always know that you've got the right tightness there, which is great. So it's clamped in two places, so there's a bit of double redundancy. And also, although you wouldn't rely on it as a connection method, you can see that this is actually cable tied onto there as well. So it's kind of, you're just never going to lose that connection at all, are you?
No, you're not. So we've got it in two places, both sides of the actual conductor itself for the protective earth neutral, which is I like. This one here is pretty obvious to me. This one's brass. There's no dissimilar reaction between copper and brass, and that's fine. Well, we used an aluminium one, Danny. He did it on purpose.
It was very good of him to do it on purpose as well. So again, you might look at this and go, well, aluminium onto copper, you're going to get galvanic corrosion. That could start to break down. And also, he's done it at this end as well. So if that one's going to break down, you might lose your connection. But actually, what's happened here is you can see that there's two things here. The little plunger at the bottom here is made out of brass. And also there's a little piece of brass gauze that's wrapped around the copper conductors as well, and that will prevent that galvanic corrosion from taking place. So again, it's really nice to see those two different styles of connection and understand that this aluminium connection is not going to cause any damage to the copper cable.
And he did that for me on purpose, which I thought was even though it was very difficult not to call him, and his name's Ryan. Mr. Hatton. So they're fantastic. So under this system, we don't need to stake our combined neutral earth because we don't believe we're going to lose that. And as always, our cable goes into our installation and feeds it.
And it's interesting to note as well that the design of this concentric cable is quite important as well, because if you look at the end of that, you can see that the combined neutral and earth conductor, the conductor that we're worried about losing, that we're worried about breaking, is wrapped around the line conductor. And that means that if by some chance, and these are buried pretty deep, so it's pretty unlikely, but if by some chance someone was to cut through this cable, what would happen is as the shovel went through there, as they were digging maybe, what would happen is that they would cut through the line conductor before that went all the way through and broke the combined neutral and earth. So actually they'd have either shorted the system out and blown something, or they would have disconnected the line conductor feeding the building and left the combined neutral and earth till last, cutting it through by accident. So again, that's another reason why we don't need to have that staked along its length.
So we've got all bases covered then. Just for my learners, again, it's in our notes that me and Joe produced. It's filled full of a resin. Just a quick one now. That resin is there obviously to make sure we get a waterproof joint, so to stop the ingress of water is an exam question. In the old days, this resin used to set rock hard, Joe. What is the problem with having a cable, maybe in a road, with a rock hard resin actually inside it?
Well, unfortunately, once you've buried this kind of connection, and I've done a few of these myself, it doesn't stay perfectly still for its lifetime. You get all kinds of vibrations going on, perhaps from the road, perhaps from even from the electricity flowing through here.
50
cycles. A little bit of vibration. And actually that resin could sometimes has broken down historically, hasn't it? It's not a terrible system by any means, but it has been known to break down. So what change has taken place nowadays, guys?
Yeah, what it is, it looks like it's set now. The new resin they put in looks like it's set, but it isn't. It actually is semi-set.
Stays kind of plastic almost.
Yeah, it does. And then obviously it can move with vibrations in the road. So if there is a vibration, traffic going over the top or the 50 hertz hum, actually it can just withstand that vibration in order that it doesn't break, because when it does break, the ingress of water, then we've got another problem. And you can see it's sealed both ends for us, ready as if it was going to have the resin poured into it for us.
So this is the modern method of connection, which reduces the need for that staked earth connection going out from here. Obviously in older systems where perhaps these cables have been cut, that is where the broken pen does start to become an issue.
And don't forget, anyone who can find a chamber in their street that says under it, the earth electrode for my PME system, I'd be surprised. I think there's a number of problems here. Historic problems is, I don't believe they've made enough neutral earth stakes throughout the run, and obviously in an aging system it's caused a problem. So modern cables have solved that problem, but of course we're going to be living with that legacy issue for many years to come, Joe.
For sure.
In this video presentation we're going to look at the cable that comes in to the bottom of the cutout. So it's the cable down here, it's black, it's often confused to be a steel wire armoured cable. However, we're going to see in this presentation that it isn't, and it's actually a concentric cable. We're also going to cut back to the classroom where I can actually show you how it would be connected within the cutout itself. Obviously I can't dismantle this one at a domestic dwelling in order to show you those connections, but I can back in the classroom. But while we're here, we're also going to reiterate some of the equipment we've got here at the intake position of this domestic dwelling. So if I bring the camera in nice and close, let's have a look at what equipment we've got here before we go back to the classroom. So this cable here is the one that's often mistaken coming into the bottom as a steel wire armoured because of its look being black and physical construction. It looks like an armoured cable. It isn't, and we'll see in the classroom what's happening with the conductors inside this cutout arrangement, an arrangement which is TNCS, terra, neutral, combined and then separated. So the line conductor comes into the fuse. The fuse can be rated at either 60, 80 or 100 amps. And then we have this combined conductor, the combined neutral and earth, TN, terra neutral combined in this concentric cable coming in, separated in the installation. 16mm earthing conductor going into the consumer unit, 25mm squared neutral conductor going into the kilowatt hour meter. We'll be able to see when we get back to the classroom what's actually happening inside here and the construction of this cable, as I've got one set up ready to show you. Let's just reiterate a few other points while we're here. The kilowatt hour meter, we've got a 100 amp double pole isolator here, so we could turn off the consumer unit the other side and work on it safely. Obviously we'd have to secure the isolation, etc. Remembering you cannot pull this fuse, it's already sealed in place. You have to get permission in order to pull that fuse out. And also our meter itself is also sealed, so we can't access the terminations in here. So if at any point you needed to access these, you need to gain permission, and often permission won't be granted. They'd come out and actually pull the fuse for you on your behalf. We haven't got that issue here because we can actually turn our consumer unit off with this isolator just here. So let's cut back to the classroom now where we can have a closer look at this cable here and see how it would be connected inside a cutout. So I've got my mimicked rig here. I've got my mimic cutout fuse, remembering the three sizes are 100, 80 and 60 amps for a domestic dwelling. We've got our 25mm squared meter tails going into our kilowatt hour meter, slightly different than the ones we've seen before. And this is our earthing conductor going out, and it's mimicking a TNCS earthing arrangement. It's the cable coming into the bottom that we're concentrating on, trying to work out what it's doing and what it is. It's one of these. It looks like that coming into the bottom like so. So it looks like that. Often mistaken for a steel wire armoured cable because of its colour of being black and physically looking similar to a steel wire armoured cable. However, when I turn it round, you can see that that isn't a steel wire armoured cable, and we've got only two conductors. A centre conductor, insulated in brown to denote that it's a line conductor, and has a silvery looking conductor there. That's aluminium, that's our line conductor. And the outer, which we think is armouring, is actually our neutral and earth, our protective earth neutral. So we've got a combined conductor here. This is a concentric cable. This isn't steel or armoured. It looks like a steel or armoured cable until you strip it back. It's a concentric cable, a cable that has a combined neutral and earth and line conductor, in this case with an aluminium material. Copper, neutral earth, aluminium for the line conductor. Let's have a look inside here and see how that's going to be connected. Okay, on this demonstration rig I will be allowed to pull this fuse. Under normal circumstances you wouldn't be allowed to pull it, and it's sealed either top and bottom or in one position in order to prevent you from pulling that fuse. In the event of requiring to pull that fuse, you need to contact your DNO in order to be given permission. For me, it's not a problem. I can pull out this fuse, a fuse that wouldn't be pulled out under load conditions. If you look there, this one's rated at 100 amps. You wouldn't want to pull that out with it drawing 100 amps. It could create a massive arc across here, and that wouldn't be safe. But for mimicking purposes, that's not an issue. Let's pull it out. Let's have a look at how we're going to terminate the conductors under here. So I undo this screw here, a screw you'd never normally get access to. And I pull that to one side, and I just lift this out of the way, like so. And if we reintroduce our conductor now, like that, okay, you can see that the line conductor would be going into the bottom of the fuse. The fuse would either be 100, 80 or 60 and go out, in this case, on our 25mm squared double insulated metering tails. And the combined neutral and earth conductor would be connected into here, where we have both the neutral going out and the 16mm earthing conductor going out. So you can see that if we go back to our original TNCS, Terra neutral are combined on the supply authority side, so a combined earth neutral on the supply authority side, and then in the installation you have a separate neutral and a separate protective conductor, TNCS. The Terra neutral are combined on the supply authority side and separate within the installation itself. You can see in here that we would connect our conductor in from the bottom and go out with a neutral and our earthing conductor, and we say for exam purposes these are connected via a solid link. In other words, in this one solid connection here you have both the neutral and the protective conductor. So let's reiterate the connections in the bottom of the kilowatt hour meter. Our incoming line and neutral from the supply authority side go line and neutral. The tails that would be connected this side are the ones that go into the installation to the consumer unit within the dwelling, and they go out neutral and line. So let's look at that again. So line, neutral in, neutral line going out into the dwelling, and obviously we take in the 16mm protective conductor as well. So our earthing conductor goes into the installation as well. So hopefully that's taken some of the myth away about the cable coming into the bottom of a cutout looking like a steel or armoured, but actually being a concentric cable. However, there are other styles of concentric cables. So if I get the next one out, it's going to obviously look a little bit different, not only from colour, but obviously from construction as well. This is what's known as a split concentric cable. This can be used for a TNS earthing arrangement. As before, we've got an insulated aluminium conductor for our line conductor. Now what we saw before was the copper, which looked like armour in, which was our combined neutral earth on our original pen conductor, is now been insulated for a number of conductors in blue, because they will be your neutral, away from the bare ones that will be your protective conductor. So this is a split concentric cable. So I hope this video has added a little bit more detail. It's looked at the incoming cable not being a steel or armoured, but being a concentric cable.